Today, we're going to break down the absolutely incredible biological machine that lets you see the world around you. So let's just dive right in with a question. Think about the phone in your pocket or the camera on your laptop. Could it be that the most powerful, most complex camera you own isn't a device at all, but it's actually the one built right into your head? The best way to understand the eye is to think of it as a super advanced camera. It's amazing, really. For every mechanical part in a camera, your eye has a living biological equivalent. The white part, the sclera, that's like the camera body. The colored part, the iris, is the aperture. The lens is, well, the lens. And the retina, way at the back, that's your digital sensor. So, let's follow a single ray of light on its journey into this biological camera, starting with how the eye controls exactly how much of that light gets in the first place.
Okay, so the first thing light hits is the iris. That's the colored part of your eye. And it works exactly like a camera's aperture. When you walk outside into the bright sun, your iris shrinks down, getting smaller to limit the amount of light that enters and to protect the delicate lens sitting right behind it.
And of course, in the dark, it does the exact opposite. It opens up as wide as it can to capture every last bit of available light so you can see. It's this brilliant, fully automatic light management system. Tucked right behind the iris is the real star of the show, the lens. This is the brightest, most critical part of the whole system. Its entire job is to take all that incoming light and focus it perfectly to create a sharp, clear image. And it's all protected by a liquid called the aqueous humor. But here's where it gets really cool. The lens does way more than just focus. See, with a normal camera, you might have to twist a dial or tap a screen. Your eye, though, has a powerful, living autofocus system that works instantly. So how does it pull this off? Well, this incredible autofocus is controlled by a set of 6 tiny muscles called the ciliary muscles. When you look at something far away, they relax, which pulls the lens and makes it thin. But the moment you look at something close up, those same muscles contract, allowing the lens to relax and become thicker. And this explains a common habit we all have. Ever wondered why you squint to read really tiny text? When you do that, you're actually physically helping those ciliary muscles squeeze the lens, making it thicker to bring those small details into sharp focus. And the reverse is totally true. When you widen your eyes to see something off in the distance, you're helping pull that lens thin. It's like you're giving your eyes natural autofocus a little manual assist. Pretty neat, right?
Okay, so once the light is perfectly focused by our amazing autofocus lens, it has to land somewhere to actually create an image. And that brings us to the eye's version of a digital sensor. Meet the retina. This is a light-sensitive screen that lines the back of your eye. It works just like a digital camera sensor, or maybe a better way to think of it is like its memory card. Its job is to capture all that visual data. The whole eyeball is kept in its round shape by this gel-like liquid called the vitreous humor. And I love this quote on the slide. It says, "This fluid keeps the eye puffy like a pani puri." What a colorful way to put it. But seriously, if that gel were to ever leak out from an injury, the eye could actually shrink. But the retina is holding on to a really surprising secret about the images it captures.
Because of the way the lens bends light, the picture that's projected onto your retina is actually completely upside down. Yeah, you heard me right. You are technically seeing an inverted world all the time. It's your brain that's constantly working in the background, flipping every single image for you so that the world makes sense. It's absolutely incredible when you stop to think about it. Now, not all parts of this retina sensor are created equal. There's this tiny central area called the yellow spot, or macula. That's your HD zone. It's what delivers all your clear, sharpest images. Then there's a literal blind spot, which is where the cable connects, so it has no sensors at all. The rest of it just captures your peripheral vision. This is exactly why a trained sniper doesn't just look at a target. They actively work to place that target right on the macula. That's how they achieve that perfect, crystal clear clarity before taking the shot. It's the eye's true center of focus. So, capturing that upside down image on the retina is really only half the battle. Now, all of that raw data has to be sent to the main computer for processing. And that happens through the optic nerve. Think of it as a high-speed data cable, sending that inverted image from the retina's memory card straight to the most powerful image processor known to man, your brain. So, let's just quickly recap this whole incredible journey. Light enters the iris, the lens focuses it, an upside-down image forms on the retina, the optic nerve sends that data to the brain, and finally, the brain flips the image and turns it all into what we experience as sight. And that just leaves us with a final kind of provocative thought. Since your brain is so actively flipping, correcting, and interpreting every single thing you see before you're even aware of it, how much of your visual world is pure reality? And how much of it is simply your brain's best guess, its own interpretation? Some to think about.